final step in removing particulate contamination and microorganisms from our drinking water is accomplished by filtration. The settled water from the clarifiers flows onto the filters by gravity and passes through the filter media, a layer of crushed anthracite coal and a layer of sand before exiting the bottom of the filter.
Anthracite coal is used because it is lighter than sand and will remain on top of and separate from the sand. Anthracite is also relatively hard and durable. As the water passes through the filter, the small flock particles stick to it or get caught between the individual particles of coal and sand.
A filter run is the time that it takes for a filter to reach its capacity for collecting flock particles and no longer produces water to our specifications. A filter run can be as long as 100 hours.
On the backside of each filter, online instruments continually check the turbidity and particle counts and sizes in the filtered water.
Turbidity is a measure of the clarity of the water using a light scatter method. These measurements are transmitted to the plant control room, where they are monitored by the plant operator and the control system computer.
At least twice per day, the accuracy of these turbidity meters are confirmed by comparing them to measurements taken in the plant laboratory. Similarly, there are routine laboratory verifications of the measurements made by all of the online instruments that continuously monitor the water quality throughout the water treatment plant.
At the end of each production run, the dirty filter is cleaned by a process called backwashing. The first stage of a backwash is the air scour, which is the introduction of air from a multi-stage blower into the bottom of the filter bed. This mixes and agitates the coal and sand, dislodging the accumulated flock particles.
Treated water is then pumped backwards into the filter drain system to wash the sand and coal media. The air is then shut off to prevent the media from washing out. During the final water-only stage of the backwash, the flock particles are carried away to disposal, and the sand and coal get organized into separate layers according to their weight, sand on the bottom and coal on top.
The backwash process takes about 15 minutes from start to finish.
Earlier in the treatment process, chlorine was used to disinfect the water against bacteria and viruses. Ultraviolet UV disinfection is a way to further reduce the risks to public health from disease-causing protozoa like Giardia lamblia cysts and Cryptosporidium oocysts. UV rays are naturally part of the spectrum of light that comes from the sun. Ultraviolet light has higher frequency and higher energy than visible light and is generated at the water plant with medium-pressure UV lamps.
These lamps are housed in quartz sleeves inside of stainless steel reactors, which the filtered water passes through to be disinfected.
In a fraction of a second, the energy from the UV light damages the genetic material of the protozoa, making them unable to reproduce and cause disease. Before the treated water is pumped from the plant to the storage reservoirs, fluoride is added to the water to protect dental health. We also combine the ammonia with the chlorine to form chloramine. This reduces the formation of disinfection byproducts and ensures a long-lasting residual to protect our water against bacteria or other organisms on its journey to your home tap.